So we started our new chapter in last video, scalar and vectors. We were done with the difference between these both quantities. So basic intro, like we are going to, this would be a quick revision series. So this is a basic intro in scalar. I'm just giving you a few second intro what we just discussed. In scalar, you will find magnitude plus units, and in vector you will find magnitude plus units plus direction as well. So this was a major difference which is even written in here. The example we discussed, these all are the examples of scalar, these are the examples of vector. I'm sure it's clear to you. So in today's video we are going to discuss about representation of vectors. So let's get started. Representation of vector. Even these representation are in two types. Representation is in two types. First is symbolical, whereas the second one is graphical. We also have another name for symbolical. This is also called as I'm writing here, this is also called as analytical. So symbolic and analytical representation means same. So let's start. Symbolical represent is simply when you write word in a bold sense, bold face letter, or either small or capital. It's like you can see the examples here, and the magnitude of these vectors are represented by these. So what does this mean? This simply means that these could be written like a bold words like this. A bold word like this F. Okay, we can also write like if we are showing magnitude, so we can write like F, and we can add these type of boxes around it. And if you want to write in other forms, so it's like we can write in small letter, bold face letter, or we can also write vector as a F and an arrow or the head which is showing oh god, so I'm sure it's clear to you. This was about symbolical representation. And even we write like this arrow, or we also make a line here like that. These all are the ways we can represent vector quantities. So I'm sure it's clear to you. Then we come on the graphical representation. And before we start graphical, you need to remember that this simply means graphical. This word even tells that this would be related to graphs or axes. It's like in graph we have two axes, x, y and z as well, because we have three space axes. So these are the axes. So word even graphical means same. So these are represented by an arrow. So first thing, these have the tail, and it shows the direction, and they have the head. So this means when these all things are present, this means there is a magnitude of any simple quantity. So this was about graphical representation. But again, for graphical representation we have other steps, like we can find by a lot of sources, a lot of things, like we have vector. But before we even start that vectors, let's go with additional and properties of vector. Let me look into if we have that. We don't have in this PDF, but since this is also important, so let's continue. This simply means that we have vector obeys three laws: commutative. This law simply means, I'm just telling you basic, if I'm writing R is equal to A plus B, or if I just write R is equal to B plus A, this means commutative law have been followed by this vector quantity. No matter if you add throw B plus A or A plus B, this will simply mean the same. So we just simply write like A plus B, that's equal to B plus A. This is about commutative law. This is the first law. Then if we talk about the second law, that's called as associative law. Associative law simply means if I just write R, which is equal to A plus bracket B plus C, this means this will be multiplied with this one, again with this one as well. Okay, but what if we just write simply like A plus B plus C? This means again the C would be multiplied with B and C would be multiplied with A. This means these are called as associative property. I'm sure it's clear to you. We also have another term, what that's called as distributive law. So distributive law is the same. Associative law was simply like if I just write M and NV, this would be multiplied, which is equal to if I just simply write these both quantities Mn, which would be multiplied with V. This was about associative property, but for here we are talking about distributive property. It would be like M plus N, and if we just multiply through a bracket V, which would be equal to MV plus NV. It's like we have just multiplied this V with this one and again with this one. So this is about distributive. This is distributive. This is associative. We also have another law which I just told you, commutative law, which was simply A plus B or B plus A. So I'm sure it's clear to you. Sorry, this would be a quick revision, so I'm just going to finish up very quickly. So I'm sure it's clear to you. Then let's move on other things like we have first vector, which is called as null vector. Null simply means 0. So either the magnitude or direction both are 0, or even magnitude is 0. This means that is called as null vector. This means the place or the area have not been covered, so this would be of course 0. Then we have another vector which is called as unit vector. Unit vector is simply defined as a vector which have direction and whose magnitude is unity. The dimensionless vector which have magnitude 1, unity simply means 1. So they have the direction but their magnitude is 1, or they only have the specific direction vector. If we take example of a unit vector which is A naught, which is equal to these all, and vector divided by its magnitude gives unit vector. So you can identify when vector it's divided by its magnitude, then just give a unit vector. Okay, then we have another important unit vectors. So we have some important unit vectors as well for this Cartesian coordination system. This is another system which is here, which we have not discussed yet. So which we have not discussed, but this simply means the unit vector which could be represented by these x, y and z axis. In x you can see there is I, in j in y it's like we can also add I plus j plus k. So this even means that we have the three axes. I is represented when we are talking about x axis, j means y axis, and k means z axis. So I'm sure it's clear to you. Then we have another vector which is resultant vector, a number of vector with the same kind of vectors. It's like if you see A, this is the A value, this is the B value, so their sum would be this one. And effect of R, resultant vector is sum. It's like even if I give you an example of like this one, again this one, oh god, I cannot make more around there. It's simply like I just make, so I'm just asking what would be the resultant. So we'll add 3, 2, 5, so this means this would be 10. So resultant vector simply means addition of all the vectors present around it. They're called as this one. Then we have another vectors, equal vectors. When the magnitude and direction both are equal, they are called as this one. You can see in this diagram there are two non-parallel. This means they are intersect. Parallel simply means which do not intersect, but in this figure you can see they are going to intersect each other, so they are called as two non-parallel vectors. Here this means they are not intersecting each other, this means they are parallel vector, and these are called a parallel vector but in opposite direction. You can see the arrow which is in opposite direction. And we have last two, position vector, where R is a vector which describe location. When we tell about the location, that's called as position vector. For suppose if we see example here, this is a position vector which we are going to tell, so this will be denoted by P, and yes, with respect to its origin we'll need to tell. And free vector is something which have the velocity of body undergoing uniform translation motion, can be displaced parallel to itself. Free vector simply means whose magnitude. So unit vector is simply not unit vector but just free vector. They can move or translate without changing its essential characteristics. Like they can even move. They're very free even if they don't change their magnitude, direction, and they're represented by an arrow. and that's not attach any specific point or space. For suppose if I give example, this is a diagram, this is x, this is y, this is z axis. So here if I just make figure like these, this is a picture. So here if I just write a and arrow, this means this is called as free vector, because they does not depend on any magnitude or direction, that's flowing like these. So I'm sure it's clear to you. We are done with these all basic information, so I'm sure you like. Bye bye, thank you for watching.